A very good afternoon to everyone. So, this is our digital electronics lab class. Okay. So, can you please switch on your videos just once so that I can understand that everyone is attentive? Yeah, just well. Others, please switch on your video once. Yeah. Yeah, Bhaskar Devnath. It's okay. Karma, okay. Abhishek Ram. Okay. Okay. So on the previous day, we have, yeah, Rohit, it's okay. You can switch on your video or you can switch off your video, whatever you want. So previous day we have done the adder and subtractor. Okay. And I told that you should write down that. I hope it is completed. So today we will do another experiment. I have made the video. I'll show you in a little while. That is the multiplexer and demultiplexer. Okay. So this week, the previous week, adder and subtractor you have to write. Experiment number 1 is adder. Experiment number 2 is subtractor. The same thing, same procedure. Everything is same. And this week you have to write the multiplexer number 3, number 4 demultiplexer. Okay. And all this experiment we are performing using the kit, using the trainer kit. Okay. And later on I'll show you that how this whole circuits can be built with the help of breadboard. Okay. I'll show you that on later. Okay. But initially, as it's a difficult situation, so I was thinking to take the way which will be easier for you. Okay. So using kit is a easier way to perform the experiments. That's why we are using the kits so that the experiments can be easily performed. Okay. And the thing that how you can write down the lab copy I have already told, but those who are not present on that particular class, please note down that first thing first you have to write down the title, then you can write objective or you may not write. So title, then theory, then apparatus used you can write, then table, then calculation, circuit diagram. So all these details should be there in your lab file. Okay. uh, so for the mm, mm, I'm showing you the video whatever I have prepared for you. I will provide the link also. Okay. I've just shown you that how the experiment can be performed using kit. So this is your experiment number 3 and 4. This will be your experiment number 3 and 4. Okay. Please pay attention and see the video of multiplexer and demultiplexer. I've shown multiplexer, demultiplexer is all same thing. You will see it. Okay. So I have already discussed about the concept of multiplexer in your theory classes. Today we perform the multiplexer and demultiplexer. As we have already discussed about what is multiplexer. Multiplexer is basically a digital IC, created in digital IC form, and it has multiple input lines, okay, and a single output line. So today we will discuss about 4:1 multiplexer. Okay, what does it mean by 4:1 multiplexer? There will be 4 number of input lines will be there, and as we all know that there will be a single output line will be there in case of multiplexer. So we have 4 input lines and 1 output lines. This multiplexer will design. Okay, we will circuit diagram to develop that multiplexer. Okay, and we perform the whole experiment in this kit. Okay, standard kit. This is basically the multiplexer standard kit. Okay, so in case of multiplexer, we know that there are different type of terminals are there. Like there will be input lines, as it is 4:1 multiplexer, so 4 input lines will be there. There will be a single output line. Okay, there will be select line. Okay, there will be select line. This select line will help us to select a particular input. That means depending on the select line, which input will be selected and pass through the circuit and appear to the output terminal, it will totally depend on the select line. So select line plays a very vital role in case of multiplexer. Okay, so there will be select line, and lastly there will be enable line. Okay, enable line means we can say it as a switch which can switch on the device or switch on off the device. Enable line is off or 0, that means the IC is not working. And when the enable line will get 1 or high voltage or 5 volt or something like that, then the IC will be activated. Okay, so these are the 4 type of terminals will be there in case of multiplexer. Number 1 is input line, number 2 is output line, number 3 is select line, and number 4 is enable line. Okay, so when we want to design a particular type of multiplexer, say suppose for example in this case we are designing 4:1 multiplexer, then we need to calculate what will be the number of select line. Okay, so depending on the number of input line, the select line, number of select line will vary. Okay, then there will be a small equation which I will show you in a little while, which is n equal to log 2 base n, and n is the number of input line and n is the number of select line. Okay, and with this formula we can easily identify what will be the number of select line. Okay, so let's draw the whole circuit diagram. Let's read the circuit diagram. Let's see what will be the table for designing a 4:1 multiplexer. We'll go in detail with all these things now. So please concentrate on my copy. I am showing you my copy and design the whole thing here in this table only. So it will be easier to discuss the whole thing over here. So we want to design a multiplexer. Okay, 4:1 marks. We'll design a 4:1 marks. Okay, so first thing first, let me draw the block diagram in case of multiplexer. So this is a 4:1 marks. You can say this is an IC. Okay, this is a marks IC, which has 4 input line and 1 output line. So let's draw the 4 input line. 1, 2, 3, 4. So these are the 4 input line. Like name it I0, I1, I2, and I3. So these are the input lines. Okay, this is our output line, which can be represented as Y, and there will be select line. So how many select lines will be there? We need to calculate it. And we can easily calculate with the formula. I have already told that m is equal to log 2 base n, where n is the number of input and m is the number of select line. Okay, so now let's calculate it. So here n, the number of n is 4, as we have 4 number of input lines are there. So m will be equal to log 2 base 4, or we can write it as log 2 base 2 square. Okay, or 2 log 2 base 2, that is equal to 2. So here growing businesses need a hosting. Sorry. Plus I1. Sorry for the interruption. Or turn on the device or turn off the device. To 2, that is 4, as we have 4 number of input lines are there. So m will be equal to log 2 base 4, or we can write it as log 2 base 2 square. Okay, or 2 log 2 base 2, that is equal to 2. So here we have got that m is equal to 2. That means there will be 2 select line. Let's draw it. So we have 2 select line. Name it as S1 and S0. Okay, I'm not showing the enable line because it's only a switch which can turn on or turn on the device or turn off the device. Okay, so this is the whole what you can say block diagram. Okay, now let's build the table. So we have 2 select line S1 and S0, and Y is the output. Now we'll see which input will be selected according to the combination of S0 and S1. So we have 2 variables, so number of combinations will be 4. 1, 1. These are the 4 combinations may be there in case of 2 variables. Okay, so when S is 0 and S1 is 0, S0 is 0, the first input will be selected, that is I0. Then I2 will be selected, I1 will be selected, and then I2 will be selected, and then I3 will be selected. So this is the table. When we want to select this particular input, when both the select line are 0, then this input will be selected. And then after, when it is 0, 1, it's 0, 1, then this input will be selected, and according to that, all the input line will be selected according to the value of select line. Okay, now let's build the equation from this table. From this table, let's build the equation. So I have already shown you that how we can build the equation. Let me write down it again. So equation will be y equal to I0. I0 is the input. When we will got I0, when S1 is 0, S0 will be also 0, plus I1. When we will get the I1, when S1 is 0, here you can see I1 is selected when S1 is 0 and S0 is 1. So S0 plus, then I2 will be selected. When I2 will be selected, S1 is 1 and S0 is 0. Here you can see S0 is 0. So now it's S0 bar plus when I3 will be selected. I3 will be selected when S1 is 1 and S0 is also 1. That means S1, S0. So now we have developed all the variables, all the inputs are there in this equation. So we have developed the whole equation for 4:1 mux multiplexer. Okay. Now let's build the circuit diagram. Okay. So we have two select line or two variable, that is S1, S0. Okay, so S1, let's take S1 this line and S0 this line. There will be bar, so let's say not get over here, and this is your S1 bar. Now we again place it not get over here so that you can get the S0 bar. Now this line is S0 bar. Okay. And now we have I0, I1, I2, I3. I will place it in a little while. Just see. I am placing it after some time because it may be hazy if I place these terminals now. Okay. So let's just follow the path whatever I am taking. So I0, S1 bar, S0 bar. So S1 bar, let's take S1 bar from this terminal. We'll get S1 bar from this terminal and S0 bar from this terminal. Okay, so now we have got S1 bar, S0 bar, and then we have I1. So I am giving I1 over here. This will give us I0, S1 bar, S0 bar. Now the second term is I1, S1 bar. So let's take S1 bar first. Now this is S1 bar. S0, we'll take S0 from here, and I1, place I1 here. Okay, then we have another AND gate. Here we will get I1, S1 bar and S0. Now this is S2, I2, S1. So we need to take S1 and S1 line is, so this is S1, then S0 bar, this is S0 bar and I2. This is I2. And lastly, and we will get here I2, S1, S0 bar. Okay. And lastly, we have this point S1 and S0. Directly we will take S1 from here and S0 we can take it from here, and I3. Now here we will get I3, S1, S0. So we have collected all the variables over here. Now there is OR operation. So we can take an OR gate, 4 input OR gate, and we can connect the output of AND gate over here, so that we can add it or we can OR everything. Okay, so this is the whole circuit diagram, and here we will get the output, that is Y. Okay, so this is the main concept. This is the main concept, and this is how we have built the whole circuit diagram. Now, please note it down. Okay, Please note it down. If it is a 16:1 multiplexer, then you have to do the same procedure, apply the same procedure. The number of select line will be vary according to your input line. Okay, the truth table will be also vary, or the table will also vary according to the select line. If it is a 3 select line, then S1, S0, S1, S2 will be there. So if it is a 3 variable, then the total number of variable will be combinations will be 16. Okay, this is how, or sorry, 8 variable will be there, 8 combinations will be there. Okay, and then you can easily build the equation, and from this equation you can easily build the whole circuit diagram. Okay, so now let's move to the kit so that we can perform the laboratory. So this is the kit. This is the kit. Let me take it. Okay, now it's everything is visible. I hope. Now everything is visible. I hope. Okay. So this is the circuit diagram for multiplexer, and the demultiplexer will be just opposite. I have already told you demultiplexer. Okay, I will do only the multiplexer portion, and demultiplexer will be same. Okay, you have got the concept. Okay, if you have faced any difficulties, I will discuss it on later. Now let's build the circuit. Build the circuit. So we have 2 select line. Let's connect the select line first. This is your input panel, and this is the output panel, and here is the circuit diagram. Now S1 and S0 is connected. S1 and S0 is connected. I have connected here. You can see. Okay, now we have given the inputs, and you can take the inputs from this line. This is for T0. Here it is written T0. I have written I0, I1. T0 means data, and I means input. 1, 2, 3, 4. This is only just I have connected the terminals. So I have connected the 4 terminals, and we get the output from this terminal, and we can see the output here. In any one you can connect it. Okay, in any panel you can connect it. So this will be the whole circuit diagram. This will be the whole circuit diagram. If I move it a little bit upper, you can easily see. Okay, connected it. So this is the whole circuit diagram. We have developed the circuit also, and now let's check the table. So when it is 0, 0, whatever input we can give here at the first input line, that is I0, that will be reflected in the output terminal. Okay. Only this input will be reflected this terminal when both are 0, 0. Other terminal will not work at this moment. You can see now this is 0, 0. This is 0. This is also 0. Now only if I put what here 1, that LED will glow. If I put 0 over here, that will not glow. And other inputs will not work at this time, because only that input is selected. Only I1 is selected. So it will work only I1. See here. When we will give 0, 1. We have given 0, 1. Now this will not work, but this will work. You can see here. Now this one is not working, but this input line will work. You can see the LED is glowing. Here the LED is glowing. You can see here. This line will not work. This will also not work. When we will give 1 0, that means 1 0. Now we put 1 0. So this line will work. Only this line will work. Other 3 line will be deactivated now. Let's see. I am switching on this terminal, but LED is not glowing at the output section. LED is not glowing at the output section, but now LED will glow at the output section. You can see. I can easily control this thing. This terminal is also not working. But when both are 1 1, only this terminal will work. You can see. Only this is working. Other terminal are not working. Okay. Other terminal is not working when it is 1 1, because now this terminal will work. You can easily visualize this in this table. When 0 0, S1 S2 both are 0, I1 will be activated. 0 1 0 0, I0 will be activated. 0 1, I1 will be activated. 1 0, I2 will be activated. 1 1, I3 will be activated. So see it again. 0 0, I1 will be activated. Other switch will not activate it. Okay. Now 0 1, it will activate. Other will not activate. Sorry, it's for cross connection it's free. This is not glowing. Only for this case it will glow. When 1 0, this switch will be activated. Other will not activate it. You can see. When 1 1 is there, only this will activate. You can see no other switches.
एक चीज कभी कभी इमेज बिगाड़ सकती है, इसीलिए गोडैडी
Sorry, the YouTube next video was playing. So I hope you got the idea that how we can perform the laboratory for multiplexer. It's also very easy. Yeah. So I will stop the recording now, okay? And I will take some question answer if you have any.